Welcome to the second part of 3.1. Here we have a little bit more to just wrap up this section, and then we'll move into the next stuff. So first, we have the slope-intercept form of a line is this y equals mx plus b. Some of you are probably familiar with this y equals mx plus b form, where the slope is m, that is the letter m is the slope, and the y-intercept is 0b. Now, we're going to be getting into this in much greater detail here in the next 4 or 5 lessons. So I'm not gonna. I just want to touch on it now, and we'll come back to it in a little bit. Now, answering these next two questions: which quadrants are the following points? And recall that when we have our plane here, and we have our x-axis, and we have our y-axis, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And those are Roman numerals. If you just use first, second, third, fourth, that's totally fine. So when we think about this first point, 100, -1, we don't need to specifically plot the point, but we know when we're going out 100, we're going out in a positive x direction, and then -1, we're going down, so it's going to be somewhere down here, and that is going to be the fourth quadrant right there. Now, when we look at this next piece, -6, -29, if we're going to plot that, I mean, we're going to go -6 and then -29, which puts us somewhere down here, which is, in fact, the third quadrant. Okay? So moving on to this next one here, we want to determine, are the ordered pairs, that is, these ordered pairs right here, are these solutions of this equation right here? So to determine whether these are solutions to this equation, we want to plug them in and see what we're doing. And we're going to go ahead and do this down here. We have a little bit of space, and we'll do this last one kind of the other side. So are these solutions of this? Well, our equation here is 4x minus 2y equals 10. So to determine whether or not this first one is, we plug this 0 in for x, -5 in for y, so we have 4 times 0 minus 2 times -5. Is that equal to 10? Well, that's 0 right here. -2 times -5 is 10. So in fact, this is a solution to this equation, and what that means is that that is a point on the graph of this line. So let's go ahead and plot this point, because it says if so. We're going to plot them below. So 0, 5 is going to be right here. And I'll label that 0, 0, -5, excuse me. So erase. 0, -5, 0 in an x direction, and -5 in a y direction. So we're right down there, and I label it 0, -5. Okay? Now we want to check and see if 4, 3 is a solution to this. So once again, we're going to plug these ordered pairs in, 4 in for x and 3 in for y, and see if it makes a true statement. So 4 times our x, which is 4, minus 2 times 3 equals 10. Well, 4 times 4 is 16. 2 times 3 is 6. 16 minus 6 is 10. So this, in fact, is a point on the graph of this line as well, because it gave us a true statement. So we'll plot this point. So we go positive 4 in the x direction, then up 3 in a y direction. Then that right there is 4, 3. So once we have these 2 points, we can draw the line that goes through them, and that's that. Now, it says here we want to find a third point on the line. So one way we can do that is by this. We can make a little t-table here. We have our x, we have our y. We can just pick any value that we want and plug it in for x. Now we've already used 0 and 4, so let's just go ahead and use 2. So this is always another way to get a point that's going to be on the graph of this line right here. Now we plug 2 in for x. So 4 times 2 minus 2y equals 10. And this turns back into a problem. It turns back into a problem like we had in the last section, where we're solving one of these linear equations. So 2 times 4 is 8, so we have 8 minus 2y equals 10. Subtract 8 from both sides. Cancellation here. -2y equals -2. Excuse me, a positive 2. Divide by -2, and we get y equals -1. So what this tells us is when x equals 2, y equals -1, that gives us another ordered pair. So we can go up and plot that on our line. So we have 2, negative 1. And notice here, my line was not drawn specifically great, but 2, negative 1, that's that point here. And if I would have drawn the line, I guess, with a straight edge, which I haven't been able to do on this program yet, it would go right through that as well. Okay. So the last one we're doing here is this. We want to graph this line, and we're going to go ahead and graph that right here. So the equation of the line is y equals x minus 3. So let's go ahead and find some points that are on the line, x and y. Now, we can pick any value and plug it in for x that we want. I am just going to choose 0 because it is very easy to work with. So plugging that in our equation right here, y equals 0 minus 3. 0 minus 3 is negative 3, so we get y equals negative 3. So 0, negative 3, that is a point on the graph of that line there. So let's plot the 0, negative 3, 2, 3, 0 in an x direction, down 3 in a y direction. Now let's we can pick any value we want for x. We've already used 0, so let's use, I don't know, 1. So plugging that in for our x in this equation here, we have y equals 1 minus 3. 1 minus 3 is negative 2, so y equals negative 2. So in x equals 1, y equals negative 2. So 1, negative 2, that's a point right there. Now 2 points uniquely determine a line. So we could go ahead and graph the line there, but let's just get one more point on this line, and then we'll do it. So I'm going to choose x equals 3. So I'm going to plug this in for this x right here. So y equals 3 minus 3. So y equals 0. So when x equals 3, y equals 0. So that gives us this point right here, 3, 0. And you'll notice as we plot more and more of these, it really does form that line. So we only need 2 points. I got a couple more than 2 on here. Trying to draw the straight line that goes through all those points, and that's the graph of that. So hopefully that made sense. We'll see you next time.